Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is NABILAH binti RUSLAN and my matrix number is DF220210. Okay, so for the introduction, water resource management, anticipating and mitigating natural disaster like flood and drought, and resolving environmental challenge connected to water quality and availability all depend on hydrological studies. Our team had 3 months to gather information for this investigation, including the 3 biggest rainfall occurrence. The station we chose for our data are in Sibu Sarawak, and we decided to use 3 months of data from November 2022 to January 2023. Here is the list of the station that we chose for rainfall station and water level station. First, for rainfall station, we choose Ulu Sungai Merah, Jabatan Laut and Sungai Teku. And for the water level station, we choose Ulu Sungai Merah. Okay, so why we choose Sibu Sarawak? It is because of we chose a station that are located in low-lying areas near rivers or in region with high rainfall intensity because they might be more susceptible to flood issues. Sibu, which located in Sarawak, has experienced flooding in the past. It is because of Sibu is located near the Rajang River, which is the longest river in Malaysia. Okay, next, the goal of this project is to use rainfall and water level data from the station Sibu to calculate the mean annual rainfall of the proposed catchment region, the peak flow of the proposed catchment location, the river discharge at the maximum water level, and the unit hydrograph.
Hi, my name is MAISARAH binti MOHAMAD NABI and my matrix number is DF220125. Next, I will explain the methodology of this project. The first one is Department of Irrigation and Drainage. For this project, our group needs to go to the Department of Irrigation and Drainage websites, which is publicinfobanjir.water.gov.my page. We can view our map using a range of map options on this website that are ideal for the needs of this project by using the website to do research on the recommended project, then how to use this website to collect data for this project, and how to use this website to create data for this project. The next one is Google Earth Pro. Google Earth Pro enables the visualization, evaluation, overlay, and generation of geospatial data. When using Google Earth Pro, we get to know terrain profiles and gradient slopes for each path, such as the minimum and maximum elevation, average elevation, total distance traveled, maximum slope, and the average slope. The figure shown is the data that we got by using Google Earth Pro. Then, by using these apps, we will gain the information about the cross-section near the water level station at upstream, cross-section at midstream, and cross-section at downstream. Next, for calculation, we will use 3 methods, which is arithmetic mean method, Jackson polygon method, and isohedral method. For arithmetic mean method, it is calculated by adding up each number in a set of data, then dividing that total by the number of elements in the set. Then, for Jackson polygon method, the idea is put into practice by drawing perpendicular bisectors to the straight lines joining each pair of rainbows. Lastly, the isohedral method. It entails drawing isohedral lines on a map to indicate regions with the same amount of precipitation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nick. My matrix number is DF220189. Now I will share about result for arithmetic mean method. Okay, first of all, we must know the equation, which is sum of pi per n. So we know pi is 54.5 plus 91.5 plus 183 per 3. So we got the P is 109.67 mm. Next, I will share about result for Jackson polygon method. First of all, we use Google Earth Pro to determine the area of station Sungai Teku 9.47, Sungai Merah 11.44, Jabatan Laut 20.29. So the equation is sum of AI area times PI precipitation per sum of area. So we know the sum of AI PI is 5276.1, and then sum of area is 41.2. So 5276.1 per 41.2. So we get the P is 128.1 mm. Okay, next I will share about result for isolated method. First of all, we use Google Earth Pro to determine the area. So the equation like before this, this is a polygon, which is P equal to sum of AI, area, times precipitation, PI, per sum of area. So we got P is 70.5 because we use sum of AI times PI is 2740 per 38.84. So we got 70.5 mm. Okay, here the result for hydrograph method. A. Hydrograph for cross section at Sungai Teku. B. Hydrograph for cross section at Hulu Sungai Merah. And C. Hydrograph for cross section at Jabatan Laut. Okay, next is result for rational method. First of all, we open Google Pro to determine the perimeter of catchment for calculation for slope area. Then the table given is for runoff coefficient for various land use. Then the data given is catchment area 41 km square. Then runoff coefficient 0.4 and horizontal roughness is 0.045. Now I will continue for the calculation for slope over land flow time and peak flow. Okay, let's go to slope over land. Slope over land is 99 minus 1 over 24,920 times 100% because we want the percentage of the slope. Next, overland flow, we got 222.9 minutes, and peak flow we got 546.67 meter cube per second. Okay, now we continue with cross section method. Here the equation for Jabatan Laut, which is P for Jabatan Laut is 271.2 meter. Now we go through next, which is Hulu Sungai Merah. We got P equal to 101.5 meter. Lastly, we got for cross section method for Sungai Teku, P equal to 200.5 meter.
Hello, my name is AINA binti Mohamad JAHARI. My matrix number 220145. So for discussion, floods in Malaysia, particularly along the northwest monsoon coast, are becoming increasingly prevalent. The hydrological system physical properties have been influenced by natural and human factors, such as heavy rains and high tides. Human-caused factors include torrential rains, forest destruction, hillside development, and poor drainage system. The hinterlands, including Kuala Lumpur, is becoming more exposed to flooding. Next, for conclusion, this report investigates the reason behind floods in Malaysia using Google Earth Pro software. The software gathers trend image and analyze geographic data for analysis, planning, and decision making. Cross-section determine watershed boundaries, and catchment area are the focus. The report used 3 methods to analyze rainfall data, including the arithmetic mean, test and polygon, and isotope method. The hydrograph show how river discharge change over time, calculated by multiplying the cross-sectional area of a river by its area velocity.